Hello and welcome to this M1 MEI video on Newton's laws, where we're going to look at a situation with some connected particles. This is January 2011, question 5. So let's have a look through the questions. So we've got two boxes, A of mass 12 kilograms and B of mass 6 kilograms, which are sliding in a straight line on a rough horizontal plane, and this is shown in the diagram. The boxes are connected by a light, rigid rod, which is parallel to the line of motion. The only forces acting on the box in the line of motion are those due to the rod and a constant force of F newtons on each box. The boxes have an initial speed, 1.5 meters per second, and they come to rest after sliding 0.375 meters. So in this situation, we have to work out the deceleration of the boxes and the value of this frictional force. That's 4 marks, and then we have to work out the magnitude of the force which is acting in the rod, and we have to say whether it is a tension or a thrust, and that's 3 marks. So let's have a look at part 1 to start off with. First of all, we need to calculate the deceleration of the boxes. Well, we're told in the question, if we just look back, that they have an initial speed of 1.5 and they come to rest after sliding 0.375 meters. So initial speed 1.5, they come to rest after a distance of 0.375 meters, and because we're looking at a situation where we're going to be using Newton's second law, F equals ma, then we need to know the acceleration of the system. So looking at that, we're going to be using v squared equals u squared plus 2as. So 0 equals 1.5 squared plus 2a we don't know, and 0.375. And solving that equation gives us a is minus 1.5 squared divided by 2 times 0.375, just rearranging, and that gives us minus 3 meters per second squared. In other words, it's decelerating, which is what we're told in the question. So let's have a look at the diagram again. We have to find the value of F. So I'm going to consider the system as a whole, and I'm going to consider both particles together. So I'm going to do F equals ma. The only two forces acting on the system as a whole there are minus F, and that's acting on each particle against the direction of motion. The total mass of the system, we just look back, 12 kilograms and 6 kilograms, so the mass is 18, and the acceleration is minus 3, we've just worked that out. Minus 2F is therefore minus 54, so F must be 27 newtons. So that's part 1. Moving on to part 2, I've repeated the diagram here. We have to calculate the magnitude of the force in the rod and state with a reason whether it's tension or thrust. So to start off with, to actually label that force on the diagram, I always assume it's a tension. You might assume it's a thrust. You have to make a decision one way or the other. So I'm going to assume that these are both tensions. So there'll be a tension acting backwards on B and forwards on A. So we'll put those on. And then you consider one particle or the other particle. If you consider the system as a whole again, you'll have a negative T and a positive T, and they'll cancel each other out, so that's not going to be helpful. So consider either A or B. I think B is a little bit easier because there's less forces acting on it perhaps. So we're going to have minus T minus F, which is 27, we know that from the previous part, is equal to the mass multiplied by the acceleration. And so it's a nice easy equation to solve. So we're going to have, bring T over onto this side, minus 27 plus 18 is equal to T. And so T is minus 9. What does that tell me? Well, it tells me I chose the wrong direction. I thought it was a tension, but a negative tension, that means the force is acting the opposite way. So the force is a thrust as T is negative. And then we can say it is a thrust of 9 newtons. Okay, so let's just go back to the earlier part of the question and see how the marks are allocated. So looking at part 1, we got 1 mark here for using a correct Suvat equation and an accuracy mark for getting down to the correct acceleration. There's then a method mark for applying F equals ma to the situation and an accuracy mark there for getting the final answer. So 4 marks for that part. And then to finish off, on part 2, we get a method mark for applying F equals ma to one of the 2 particles. You could have done it for A. If you'd done it for A, you would have had T acting forwards and F acting backwards, and you would have got the same answer. We get a follow-through mark for correctly working out the tension using the acceleration that you found earlier. And then there's an explanation mark for correctly saying that if it comes out negative and you had it pointing backwards on the diagram here, then it must be a thrust pointing the opposite way. So 3 marks for that one. If you'd like to look at any of the other revision videos, go to our website www.furthermaths.org.uk.